As you can see, we're combining 4-4 and 4-5 today. The lessons are so similar, it's kind of silly to split them up. We'll just do it as one. We are going to do a little bit of additional practice for bell work tomorrow on this as well. This is something that I even remember from geometry. Like, it was one of the bigger deals in geometry. Here you have abbreviations: SSS, SAS, ASA, AAS, and HL. What these stand for, and the first one is side, side, side. So what does that mean? It's an abbreviation for an entire concept. What it means is that if you have side, side, side congruence on both of these triangles, then these two triangles are completely congruent. So we can say that triangle ABC is congruent to triangle DEF because all three sides are congruent. You have side, side, side congruence. Then we have SAS. What does the A stand for? It stands for angle. So SAS is side, angle, side. Okay, what is...
Between sides.
And it does have to be, he said angle between sides, and it does have to be exactly in between those sides. So it would look like this: side, angle, side, side, angle, side. Notice how they're like right next to each other. It has to be consecutive. Side, angle, side, side, angle, side. And if you have side, angle, side congruence, then you can say that your triangles ABC is congruent to triangle DEF. The next one, as you may predict, is angle, side, angle.
Side in between angles.
Correct. So what does this look like? Angle, side, angle. Angle, side, angle. And again, it has to be right next to each other. The side does have to be right in between those two angles. And then if you have angle, side, angle, side, angle congruence, then you can say that the entire triangles ABC is congruent to triangle DEF.
I'm sorry, I mean.
Logan, quiet. The next one is angle, angle, side. And again, they do have to be consecutive. So we have angle, angle, side, and if we do have that congruence, then we can say triangle ABC is congruent to triangle DEF. And the next one is HL. What the heck does that stand for? It stands for hypotenuse leg. Hypotenuse is something that's only used with right triangles, and this theorem can only be used with right triangles. So just make a note that this is only for right triangles. So hypotenuse is the longer side on the opposite of the 90-degree angle. So we'll just mark that the hypotenuses are congruent, and then one of the legs are congruent. And if you have a hypotenuse and a leg that's congruent, you can say that those two triangles are congruent. So triangle ABC is congruent to triangle DEF. So what is not here that can't be used to prove congruence? There's one that you may have been like kind of looking for. This one, ASS, is not a congruent statement. If you get a cuss word, it's not it.
Oh.
Or SSA, which would be the opposite, like backwards cup word. That can't be a congruent statement either. The only time it can, and I have a feeling this is what, here, you have angle side, side, ASS here, but they don't call it that, they call it hypotenuse leg. So if you have a right triangle, the ASS one does work, but only right triangles. And yes, I'm recording this. Oh well. Now we're going to move over to the workbook and see how this is actually applied.
At least we're talking.